Hello friends, welcome to this course on Abaqus. In the previous lecture, we are working on a beam problem. Until now, we have created a beam section and we have assigned this beam section to the part. After that, we are going to go to the next step. And the next step in creating the analysis is we need to create the instances. So till now, we had followed the 5 steps and we have created a section assignment. Now we need to create the instances, then step, boundary condition, load, mesh, job and result. So go to Abaqus. Now we need to create the instances. So basically instance option is very useful when we work on assemblies. So go to this assembly option. So right now we don't have any assembly. We have only one single part and we are going to create instance of that. So click on this option of instance, make a double click on this. And now we can see our part is highlighting. Just select this part option. Now our beam part we have created is showing. Select this dependent and click OK. Now an instance has been created. So whenever we work on assembly, we need to create the multiple instances. So that is where this option is useful. After that, we need to create the step. So I go to this option of step. So make a check on this minus sign and go to step. Double click on this step. So in step option, we are going to tell the software that what type of analysis we are going to perform. So in this we have multiple options, like we are going to select temperature, displacement, thermal problem, implicit, explicit. So right now we are going to solve this as a static general problem. So the procedure type is general and it is static. We can insert some name to this, like this is linear beam. And now insert the new step after initial. So in Abaqus we need to define at least 2 steps. First step will be initial step and the second will be the step we are going to define as a linear problem. So go to continue and after that we need to insert some basic description to this. So we can specify some description and then the time period. So since we are solving this problem as a linear problem, so we are going to define this for a time period of 1. Whenever we solve any problem for a longer period of time, for example, when we work on dynamic problems, we need to increase the time period. Okay. Then there is option of nonlinear geometry. So right now we are solving this problem as a linear problem. When we solve the nonlinear problem later in the course, we will know about these options. So right now I'm selecting this as a off, and then there is a incrementation option. So automatic and fixed. So we will cover these options later in the course. So these are basically the steps by which the Abaqus is going to solve this problem. So take these values as default as defined by the software. Okay, then other. So everything we are going to take this as a default and click OK. So now we have defined what type of analysis we are going to perform. After that, we need to define the boundary condition and loads. So below we have the option of BCs, that is boundary condition. So go to BCs, make a right click and click on create. The name is BC. Now steps. So here we are going to use the initial option. So in the initial step, we are going to fix our geometry. So here we are going to tell the software that onto which point the geometry is fixed. Okay, so category is mechanical and the type of selection I am selecting displacement and rotation. I am going to fix the rotation and displacement. So click on continue. Now we need to select the region where we want to fix this. I want to fix this beam from the left side. So click on this node. Now this point is selected and click done. So I want to fix this beam in the U1, it means X direction, U2 that is Y direction, and UR3 is the rotation with respect to third dimension, that is with respect to Z axis. So make a check on this. So I want to fix all these degree of freedoms and click OK. So now we have created the boundary condition. Now we are going to define the force. So to define the force, we need to go to this option of load, make a right click and click on create. And now we are going to define this force in the step we have created, that is linear static beam. Select this and the category is mechanical. Here I am going to select that is concentrated force. Here we have some more options like movement, pressure, surface traction, pipe force, etc. So all these options are for different type of analysis. I am selecting concentrated force and click continue. Now we need to select the point where we want to apply this force. So I want to apply this force onto this endpoint. Click here and click done. And here we need to specify the value of this force. So it has CF1 and CF2. So concentrated force I want to apply only in the X direction. So only insert the value in X direction. So the positive axis going, we can see from this axis, is going in the right direction. So insert the value of force, that is 1, after that 50. And in the Y direction there is no force. And the amplitude is, I am selecting RM and click OK. So when I zoom out from here, we can see the symbol for the force. So it means we have created the load and boundary conditions. So after we have created the step, boundary condition and load, we need to create the mesh and job. Now we need to create the mesh. To create the mesh, I go to this part once again. Okay, so this is model. So make a check on this. So expand this model. In the bottom we can see mesh. Right now this mesh is showing empty. So make a double click on this mesh. And now we can see right now we are in the mesh workbench. So it is module, that is mesh. If I click on this arrow, we can see part, property. So all these options are according to the steps we are following. So right now I am the mesh module. So here we have some option like seed part, then mesh part, etc. Also the similar options are available from the top. So we can select this option from here or also from here. First thing, we need to seed this. Click on the seed and click on part. So in the seed we are going to define that how many number of elements we are going to create. So let's say I'm selecting this 10 and click OK. So all these symbols are highlighting are the division of this beam. I click on done option from here and then go to mesh and go to element type. Now it is showing select a region, so select this region and click done. Here we are going to tell the software that we are going to do the mesh for a beam problem. So select beam here. This is standard and geometry linear and click OK and click done from here. And now we are going to create the mesh. So go to mesh, go to part, and now it is showing OK to mesh the part. I am selecting yes. And now the mesh has been created. Okay. So after we create the mesh, all our steps are done. Finally, we have to create the job and then we have to submit that. Now to create the job, we can go to this job workbench from here, job. Okay. Also, we can go to this model tree. In the bottom, we have analysis and go to job, make a right click and click on create. So give it some name like job beam, and for the model, that is model 1, click continue. Here we are going to tell the software that what type of memories we are using. Like in general how many of megabyte or gigabytes of memory is used into this analysis. Just take all these values as default and click continue. Then go to this job beam bottom, the job we have created, make a right click. Here we can select the data check before submitting the job. So click on the data check. So by this option the software is checking that all the data are proper or not. We can also check the status from here. Just select this job manager option. So after that we need to submit this job. So click on this submit option, click OK. And now the software is going to solve this problem. Now the status is showing running, and now it is showing the analysis has been completed. After that, we need to click on this option of result. So in the next lecture, we are going to understand how to view the result. Okay, so till now our analysis has been completed.